Okay, so we are going to look at lesson 3, and this discusses cylinders. So I kind of filled out this above information already about cylinders in general. And so a cylinder is where the bases are both circles, but is not a polyhedron. So we have circles on both bases. That's what that's saying. Okay, so this would be like a can of soup or a can of soda or something like that. That would be a real life example of a cylinder. So the volume of a cylinder is pi r squared times the height. So you're basically taking the area of the base, so the area of the circle, and you're multiplying it by the height of the entire cylinder. So if we look over here, we have the height and we have the radius of our circle, which if you remember correctly, that's half the diameter. So that's half the distance from one side of your circle to your other, as long as it's going through the center. The other definition we have here is an oblique cylinder, and that is a cylinder with bases that are not aligned one directly above the other. I'm sorry. So that would be like having something like this, which that looks absolutely horrible. Let me try that again. So it would have something where you have both your bases are circles, but they're just not directly on top of each other. Okay. Still not the best picture, but sorry. Let's move on then to example 1 so we can actually put this vocabulary and put this formula into use. So it says, find the volume in terms of pi and to the nearest whole number. So if we want to find in terms of pi, that just means that we're leaving pi in our answer. So let's look. The volume is our pi r squared times our height. So we need to figure out what our radius is for r, and we need to figure out what our height is for h. Okay, so we know here this 2 is representing the height of our cylinder. And it says D here is equal to 7. That means diameter. So in order to find radius, you have to take half of the diameter. So we're going to take that 7 and divide it by 2, which gives us 3.5 as a radius. Okay, so we can go ahead and we can plug in all of our numbers here. So we're going to say pi times your 3.5 for your radius squared. And then we're going to multiply that by the height, which we know is 2. Okay, now, the first part here says it wants it in terms of pi. So basically, you're not doing anything with this pi. All you're doing is taking the 3.5 squared and multiplying that by 2. And that gives you 375. Which that doesn't sound right, actually. Hold on. That gives you 24.5. Sorry, I was looking at a different example. So that's going to give you 24.5. And I messed that up too. All right, let's look here. 24.5. And then we're leaving pi in our answer. Okay, so if we leave pi in our answer, this would be our final answer. Now, most of the time, we don't want to have decimals when it says in terms of pi. So we can convert this 24.5 into a fraction, and it's actually going to give us 49 over 2 pi feet cubed. Okay, and we always want to make sure that we have the feet cubed because we're talking about volume. Okay, then it says, well, find it to the nearest whole number. So this time we're going to take this 24.5 and we're going to multiply it by the pi symbol. Don't multiply it by 3.14. Go ahead and multiply it by pi. So if you do that and you round to the nearest whole number is going to be 77 feet cubed. Okay. let's look at number 2 then, because this time it says, well, give your answer from example 1. So we're looking back at our example 1 and convert your answer to cubic inches. So we kind of talked about this in lesson 2 as well. With converting into inches, we need to know that there are 12 inches for every foot. So since we're talking about volume, we're talking about cubic units. So we're going to take that 12 times 12 times 12, and we get that same number we got from lesson 2. We got 1,728. And this time we're going to take that final answer and we're going to multiply it by the 1,728. Now, some teachers do this a little differently. They do conversions. I don't particularly do that. You'll see conversions in like chemistry as well, but I don't use conversions for these. I use this 1,728. Okay. So once you multiply the 77 times the 1,728 to get the cubic inches, you're going to end up with 133,056 inches cubed. Okay. Moving on. So if we look at example 3 now, it says find the value in terms of pi. This right here would be considered an oblique cylinder. That means that the bases are not one on top of the other. So see how our circles here are a little off from being right on top of each other? That would be considered an oblique cylinder. So let's go ahead and look for what we need. We know the volume of a cylinder is pi r squared times your height. Okay, so we need the radius and we need the height. So if you look down here, let's see, we have a radius right here, and it's telling us that that's 5. And we have a height of 15. So let's go ahead and let's plug those numbers in. So we're going to say volume equals pi times our radius of 5, and square that number, times our height, which is 15. So if we want it in terms of pi first, we're going to take the 5 squared times the 15. And that's going to give us 375. And we can't forget to leave that pi symbol in there. We're not multiplying by pi yet. So for the first answer, we're going to get 375 pi. And our units are going to be centimeters cubed. Okay. Now, to find to the nearest whole number, all you have to do is take that 375 times pi in your calculator or on your phone, and that's going to give you to the nearest whole number 1,178 centimeters cubed. Okay. Looking at number 4, it says use the figure from example 3. What is the area of a horizontal cross section? So what that's asking is that horizontal line going through, what is the area of that cross section here? So that's the area of one of your bases, basically. Okay, that's going to be the area of a circle. And we know how to find the area of a circle. We should know how to find the area of a circle from previous units, and from lesson 2, I explained that the area of a circle, hold on here. The area of a circle is equal to pi r squared. Okay, so we're going to take pi times our radius, which we know is 5, squared, and that gives us 25 pi. Now, if we're talking about area, you're using your units and you're just squaring your units because that's area. Now, 25 pi centimeters squared would be a good answer, or if it asks for you to give that as a decimal answer, we could say that this is also 78.5 centimeters squared, and that would just be you taking 25 times pi, okay? So either one of these answers we would accept because it does not specify in the directions what it wants. Okay, let's move on here. So the farm where you just started working has a vertical cylindrical oil tank that is 2.5 feet across on the inside. The depth of the oil in the tank is 2 feet. If 1 cubic foot of space holds 7.48 gallons, how many gallons of oil are left in the tank? Okay, so the first thing that we want to do here is we actually want to find the volume of our tank. So I'm going to draw, and we all know how well I draw. So if we have an oil tank, and it's a cylindrical oil tank, it's going to look something like that. Okay, and it says it's 2.5 feet across on the inside. So that means this whole entire distance is 2.5. Okay, and then it says that the depth of the oil tank, so that means its height, basically, how deep it is going to be 2 feet. Okay, so let's go ahead and let's find that volume first. So we know that volume is pi r squared times h. We're going to be using that for all our cylinders. Okay, and so we get pi. Now, our radius, we don't want to say that's 2.5 because 2.5 is the distance across this entire thing, and we only want half of that. So we're only wanting to go from here to here for our radius. Now, if we do that, we can take that 2.5 and we can divide by 2, and that gives us 1.25. Okay. So we're going to go ahead and put 1.25 in for our radius. Now the height we know is 2 because that's the depth of our oil tank. So we're going to say times 2. So if we multiply all of that together, we end up with 9.82. Okay, and it says if 1 cubic foot, this is feet cubed, of space holds 7.48 gallons, about how many gallons of oil are left in the tank. So if we just, if it was empty and we're trying to fill this, what we need to do with this number, since it has this many cubic feet, so 9.82 cubic feet, we're going to take that and we're going to figure out how much oil can it hold in gallons if we multiply this by 7.48. And if you do that, you end up with 73.4 gallons. Now, it says approximately how many. I'm going to say, we're going to round this, so approximately 73 gallons. I'm just rounding to the nearest whole number. Okay. And just a reminder, please, if you're having questions on any of this stuff, please contact your specific teacher for your geometry class and they can help you out more. Okay, so let's look at number 6. It says the volume of a cylinder is 9,675 pi meters cubed and has a height of 43 meters. So what is the diameter of its base? So what we need to do here is we need to go ahead and draw our cylinder. Okay, and I'm going to go ahead and label what I know. It says the height is 43 meters. Okay, but it doesn't give us the radius or anything like that to find the diameter. So we're going to look back at this information it gives us at the beginning. It gives us that the volume is 9,675 pi meters cubed. So if we look at the formula for the volume of a cylinder, it looks like this. And we can go ahead and plug in what we know already. So we know that the volume, so V, is going to be 9,675 pi. We also know pi is going to stay the same. I'm sorry, this was pi r squared. Pi stays the same. We don't know the radius, so I'm going to go ahead and leave that as r squared. And we do know the height is 43. Okay, so we can actually solve this. So if we look, we have pi on both sides, and those can go ahead and we can cancel those out. So what we're left with is 9,675 equals 43 times r squared. It doesn't matter what order, if the 43 is before the r squared or after. I think it makes it look a little better if we put the 43 before, because now we're taking that 43 and we're multiplying by r squared. So in order to kind of reverse that and solve for r, we're going to go ahead and we're going to divide on both sides by 43. Okay, and whenever you do that, you end up with 225 equals r squared. And now we know how to solve for r because we've been working with quadratics like this. So we're going to go ahead and we're going to take the square root on both sides. And that leaves us with 15 equals r. Okay, but the question isn't asking us for the radius. It's asking us for the diameter. So what we need to do with that radius is we need to go ahead and we need to multiply that by 2 in order to find the entire distance across the base. So that's going to be 15 times 2 is 30. 30, let's see, meters. Okay. All right, let's move on then to number 7. So with number 7, it looks a little confusing. There's two different shapes, I would say, here. So we need to look at both shapes and kind of split this apart. So if you look, we have a prism over here. So let's go ahead and let's look at that orange figure first. Let's look at that prism. So with a prism, we talked about that in lesson 2. So we know the volume of our orange figure, our prism, is going to be the area of the base times the height of the figure. So the base looks like it's going to be a rectangle because I have a length of 11 times a width of 6 here. So we're going to go ahead and we're going to say 11 times 6 for our big B. So that takes care of our area of our base. And then we're going to multiply that by the height. And so the height of our entire prism here is 12. So we're going to take that times 12. If we do this, we end up with 792 inches cubed. Excuse me. So that is going to be the area of our orange figure. I'm sorry, the volume of our orange figure. Now, we also need to look at our other figure. Let me change colors here. So if we look at the other figure, we're looking at this. Now, this looks like a cylinder, but it's kind of only half of a cylinder. So whatever we come up with for the volume, we're going to have to take half of that. So let's look and see what we can find here, because it doesn't give us much information. Sorry. So looking at this, if we know this is 6, we also know this is going to be 6, which means that in turn, this is going to be 6. Okay, so we can kind of say, all right, well, if we know all of these are 6, this right here is going to be our height. Okay, that's going to be our volume of our cylinder. And so that 6 is our height. And we still need to find our R, so our radius. So I'm going to erase just a little bit here so that we can kind of see what's going on. So this is 6. Now, it tells us from here all the way over here is 17. And we know that this portion is 11. So in order to find the remainder, we're going to take 17 minus 11, and that leaves us with 6 here. Okay. And since this is only half of a cylinder, that is our radius. So I'm going to go ahead and put a 6 in here as well. Okay. So we end up with, if we multiply all of this together, we end up with 216 pi. I'm going to go ahead and leave my answer in terms of pi for now. Okay, so 216 pi. Now, the problem is this is I keep saying area. The volume of our entire cylinder, but we only have half of a cylinder here. So I need to go ahead and take that and divide that by 2, and that leaves us with 108 pi. Okay, so I just took the 216 and divided by 2. So I get 108 pi. Now, in order to find the volume of this entire figure, we now have to add both the orange part and the red part together. So all I'm going to do is take the 792 plus 108 pi. And if you add all of that together, you get 1,131.3. Okay, and looking back at the directions, it says it wants it to the nearest whole number. So since this 3 here is smaller than 5, we're going to go ahead and leave it as 1,131, and this will be inches cubed. Okay. All right, moving on to number 8. So normally we would show you guys a video to kind of describe number 8 on GeoGebra, but since we aren't at school, it's just something that you're going to kind of have to see. So describe the solid of revolution generated by revolving the region around the fixed line. So that's like me saying I'm going to revolve this right here around this line. So I'm just going to turn it around that line. So if I start turning it over here, if I were to flip it, it's going to be like this. But if I'm turning it all the way around, I'm going to create that circle. So this is actually going to be a cylinder. And I know, I understand that's kind of hard to see, and I'm sorry guys, but hopefully if we get back to school before the end of the year, then we'll be able to kind of show you that in person. But then it's asking for the same thing with the second part. So I'm just going to kind of flip it across here. And then what I do is kind of fill in here. Okay, so we have another cylinder, but we have that point at the top. And we're actually going to be talking about that in later lessons. So this is a cylinder with a cone on top. Okay. All right, moving on to number 9. So, with number 9, it says the rectangle was rotated about the given line. What shape does it create? And what would be its volume in terms of pi? So, this is using kind of what we learned in number 8. So, it's telling us for part A, rotate this about the x-axis. And we know our x-axis is right here. Okay, so if we rotate that around that x-axis, that means that we're going to be down here, and this is going to be our cylinder. So we're creating another cylinder. Apparently I can't spell. If you're in my class, you know that already. Okay, so we're creating a cylinder, and with this cylinder, it's wanting us to come up with the volume of the cylinder in terms of pi. So we know that the volume of a cylinder, again, is pi r squared times h. So we have to come up with the radius, and we have to come up with the height. So if you were to turn your paper, oops, sorry, I'm trying to turn my tablet. So if you were to turn your paper, I'm going to erase some of this, and I'll redraw. Apparently I erased the Y too. That's kind of where, so your height is going to be this right here, okay? And so all we're going to do is we're going to count. We're saying 1, 2, 3, 4 units for my height. Okay, and then it's asking also, you're going to have to find the radius. Well, since this is the entire diameter, your radius is only going to be half of that. So it's only going to be 1, 2 units. Okay, and we can go ahead and plug that into our equation. So we end up with volume equals pi times our radius of 2 squared times our height of 4. Okay, and since it's in terms of pi, we're not going to multiply by pi yet. We're just taking the 2 squared times 4, which is going to give us 16, and we have 16 pi. So that's going to be our volume for part A. So 16 pi, and since we don't have like inches or anything like that, we're going to say units cubed, and I'm just going to put U cubed. Okay, let's see. B is very, very similar, okay? So it says this time, though, we're going to rotate about y equals 2. In the equation y equals 2, we're going to go to 2 on our y-axis, and we create a horizontal line there. Okay, so that's where we're going to rotate that about that line. So this time, we're going to have a cylinder up here. Okay. So we still have a cylinder, which is going to be common with these, okay, types of questions. You're going to have a cylinder most of the time. So we have a cylinder, and we need to find the height. So we're saying 1, 2, 3, 4 units. So we have a height of 4, and we have a radius of 1. Let me go ahead and change colors. It's kind of hard to see. Of 1, 2. Okay, if you notice, part A had a height and a radius that are the exact same. So if their height and the radius are the same, that means the answer is going to be the exact same. So 16 pi units cubed. You could do all the work again, but you're going to show the exact same work you did here in order to get that 16 pi. Okay. So this time for number 10, it says we have a cylindrical can. So I'm going to go ahead and I'm going to draw a can. Okay. And it says it has a radius of 1 inch. So we're going to put 1 inch here. Okay. And a height of 2 inches. it says that this can is full of water. Okay, the water is poured into a beaker that has a radius. So I'm going to go ahead and I'm going to draw a beaker as well. Okay, and the beaker has a radius of 1.5 inches. And it has a height of 2 inches again. Okay, will the water overflow when poured into the beaker? So we need to figure out which one of these has a bigger volume. If the can has the bigger volume and we go to pour the water into a beaker, it's going to overflow that beaker. But if the can has a smaller volume than the beaker, that means that it's not going to fill up that beaker. So we need to figure out which is true. Okay, so let's go ahead and let's find the volume of the can. Okay, so volume equals pi times our radius is 1 squared. Okay, and then we're saying times our height, which is 2. So if we just leave it in terms of pi, that's going to be 2 pi. Okay, but then we need to look at the beaker also. Okay, the beaker is volume equals pi times our radius, in this case is 1.5 squared, times our height of 2. Okay, so you want to take that 1.5 and you want to square it. So 1.5 times 1.5 gives us 2.25. And then times that by our height of 2 as well. And that's going to give us 4.5 pi. So if you look, is 2 or 4.5 bigger, you're going to say that the beaker is going to have the bigger volume. So if you go to pour that can into the beaker, it's going to fit because it has a larger volume to pour into. So we're going to say yes. I'm sorry, no, it won't overflow. Because the beaker has a larger volume. Okay. All right, last question for lesson 3. So it says water is pumped into an empty tank at a rate of 4.15 cubic inches per second. If the tank is filled after 2 hours, calculate the volume of the tank. So the first issue is it's saying that it fills it at 4.15 cubic inches per second. Okay? And we are talking about hours here. So if it's 2 hours, we need to figure out how many seconds are in 2 hours. So if you look here, we have 60 seconds in a minute. Okay, and there are 60 minutes in an hour. Okay, so we're going to have to say, well, if we have 60 seconds, we're going to have to multiply that by 60 to get how many seconds are in one particular hour. All right, and then we have to multiply that by 2 because we have 2 hours. So we have 7,200 seconds in 2 hours. Okay, now it's saying that it fills it at a rate of 4.15 cubic inches per second. So we can go ahead and we can take that 7,200 and we're going to multiply that by the 4.15 to figure out what the volume is. So we're going to take that times 4.15 and we get 29,800 880. So that means that our volume of the cylinder, or the empty tank, is 29,880 inches cubed. All right. That is all for lesson 3. So, hopefully this helps. And if you still have questions, please contact your specific teacher.